Now we will see the MCQs in the motion worksheet. So you can see here problem number 1. The graph represents the part of the journey of the car and what distance does the car travel during this part of the journey. So you can see this is the graph which is the speed time graph. On the y-axis we have a speed in meter by second. On the x-axis we have a time in terms of seconds. So here they are asking us what is the distance the car has traveled during this much time, that is during this 30 seconds time. And we know that the speed is nothing but distance divided by time. So distance is what? Distance is nothing but the speed multiplied by time. So here I can write distance is equal to speed multiplied by time. And we know that in the speed time graph, the distance is given by the area under the line or area under the curve. So you can see this area is giving us the value of the distance traveled by the car. And you can see here this is nothing but the triangle, this is nothing but the right angle triangle, and the area of such right angle triangle is nothing but half into base into height. So here this is a rough calculation which is nothing but half into base into height. So in this figure you can see this is nothing but the base time is nothing but the base here. The base of this right angle time is nothing but from 0 to 30 seconds. So it is nothing but the 30 seconds. So I can write into half into 30 seconds. And what is the height? You can see it is nothing but this line which is 0 to 20 meter by second. So this is nothing but 20. So here I can write 20. So half into 30 into 20, that is nothing but equal to 300. That is nothing but equal to 300, and the unit of the distance is nothing but meter. So our answer of this question is nothing but 300. So whenever area distance is called, distance is to be found, then we have to just calculate the area under the curve. Now the question number 2. A car is moving downhill along a road at a constant speed. Here you can see it is a constant speed. Which graph is the speed time graph for the car? So here the options are given in terms of speed and time directly. So you have to see carefully. This is not a distance time graph, this is a speed time graph directly. And they are asking for the constant speed. So since this is a direct speed time graph, we can see here in this case the line is given along the x-axis. This speed time graph is this along the time and along the time axis only. So here we can say speed is nothing but 0. Okay, so this cannot be our answer. In B question, the option number B, you can see the speed is this is the line for speed time graph, and here the speed is increasing. Okay, speed is increasing at the constant rate with the time. So this cannot be the graph. The part C, option C, you can see the speed is constant. As the time is increasing, speed value is nothing but constant over here. So this can be our answer. Okay, and here the speed is decreasing with the time. So this cannot be our answer. So option number C is the answer. Suppose it was the distance time graph, then what could be our answer? You can see in the distance time graph, the slope is nothing but the speed, and constant speed is there whenever we have a straight line. So option number B, we have a straight line. Option number D is also a straight line. So here we could get the positive constant speed. Here we could get the negative constant speed. Okay, if it was the speed time, sorry, distance time graph, then option number B and D would be our answer. But they are asking directly the constant speed in speed time graph. That's why option number C is our answer. Here, the problem number 3. The ball is thrown upwards. What effect does the force of gravity have on the ball? Okay. So here, whenever the any ball is moving in the under the gravity in any direction, we know already, we had also seen such question in the practice problem as well. Whatever is the direction and the speed of the any object, yeah, under the gravity, gravity always pulls the object in the downward direction only, and that's why we can say the answer is only towards the downward direction. G is the symbol for the acceleration, for the gravitational acceleration. So here option number A, it produces the constant acceleration downwards. So this is our correct value, correct option. So always remember, it is a constant value that is close to 9.8 meter by second square. It is always downward. So option number A is the correct option. Option number B, they are given constant but upward. This is incorrect. This is decreasing, upward. Option number D, increasing and downward. All are incorrect. Only it has a constant magnitude and the downward direction. Here, question number 4. The diagram shows the speed time graph for a train as it travels along the track, and which part of the graph is the train speed changing at the greatest rate. So in this case, they are asking for the greatest rate, that means the highest acceleration. Okay, we know the acceleration is nothing but the rate of change of the speed, and this slide image I have given here for the reference. If the y-axis is the speed and x-axis is the time, and we know that the speed time graph, the slope, that is del v divided by del t, that is change in the y-axis divided by change in the x-axis, is nothing but the acceleration. And we know that steeper is the line, then we will get the highest slope, and the highest slope in this case is nothing but the highest acceleration. So it is a speed time graph given over here, and the slope of the speed time graph is nothing but acceleration. And the steepest line, you can see this RS is nothing but the steepest line. So PQ is the horizontal line, so acceleration, you can see it is 0. For QR, we will get some positive value of the acceleration. For RS, we will get the negative value of acceleration, but the magnitude will be highest. And again, for ST, we will get some negative value, but the value is smaller than the RS value. So here for RS, we will get the highest rate, that means highest acceleration, because this is the steepest line. Okay, and if the line is steepest, the slope is also highest. So option number C is the answer. Now question number 5. The diagram shows a speed time graph for body moving with the constant acceleration. Here this is a speed time graph. What is represented by the shaded area under the graph? So we know that whenever there is a speed time graph, the area under the curve, that is nothing but this area, will represent the distance. Okay, because the area is nothing but given by the speed multiplied by time, and speed multiplied by time we had just seen in the question number 1. The speed multiplied by time is nothing but the distance. So the area is representing the distance. Okay. Option number A, C and D, all these are the acceleration, speed and time. These are not the correct answer. Question number 6, you can see the car accelerates from traffic lights. The graph shows how the car speed changes with the time. How far does the car travel before it reaches the steady speed? So you can see this graph is the speed time graph, and at 0 second the speed is 0, and speed is increasing continuously till it reaches the 10 second. At the 10 second the speed is nothing but 20 meters per second, and after 10 second it is constant. So before it becomes a constant, because they are asking how far does the car travel before it reaches the constant speed. So before it reaches the constant speed, it has traveled for 10 seconds. And how much distance basically it has traveled before reaching this 20 meter by second value. So this we know already the distance time graph, sorry, the speed time graph, the area is to be calculated to find out the distance. So here we can find out this area. Again, I do here the rough calculation. The area is nothing but here the area is nothing but half into base into height. So here half into the base of the graph is nothing but, you can see this is nothing but the right angle triangle, and here the base is 10 and the height is nothing but this is equal to 20 meter by second. So this height is on the y-axis, you can see this is 20. So the value, if you calculate this value, nothing but it is nothing but half into 20 into 10, that is nothing but 100 meter. So our value is nothing but 100 meters, that is option number C. Okay, all other answers are incorrect. So here it is nothing but the area under the line, that is nothing but 100 meter, option number C. Now the seventh question, a small steel ball is dropped from the low balcony. Ignoring air resistance, which statement describes its motion? So it falls with the constant acceleration, it falls with the constant speed, it falls with the decreasing speed, and it falls with the increasing acceleration. We know that whenever any body is moving freely uh, in the gravity, it has a constant value, and that is in the downward direction. So it has a constant acceleration, that is nothing but the correct answer. It falls with the constant speed. Whenever the object is falling down, okay, the speed basically increases. Okay, so the constant speed is not answer. Speed increases. Here, option number C, it falls with the decreasing speed. As I just told, the speed is increasing in the downward direction. In the upward direction, basically it decreases. Okay. Here D is given, it falls with the increasing acceleration. And acceleration should be constant, so it cannot be the answer. So option number A is the answer. Then question number 8, a man stands by a railway track. This man is over here. The train is given. A train traveling at 40 meters by second takes 2 seconds to pass the man. What is the length of the train? So you can see this train is traveling in this direction, and it is traveling with 40 meter by second speed, and it takes 2 seconds to pass the man. So you can consider only this initial point of uh, the initial point, and this is the final point of the train, and it starts with this initial point, and when it passes this man, then this point is also passing the man, and from this point to this point it takes about 2 seconds. That means if we calculate the distance covered or passed between these 2 points, okay, initial point and the final point, then that would be the length of this train. Okay, so to calculate that length, we have to use this formula. The speed is equal to distance by time. So here distance is nothing but the length of the train itself. The distance will be equal to the speed multiplied by time. Here the speed is given, that is nothing but 40 meter by second. So speed is 40. The time is given is nothing but 2. So here 40 multiplied by 2 is nothing but 80 meter. So our answer is nothing but the 80 meter. So option number D is the answer. Okay. So here the distance is nothing but the Distance itself is the length of the train. This is nothing but the distance covered between passing while passing these 2 points, which is nothing but the initial point of the train and the final point of the train. Then question number 9. A snail moves along a ruler. It takes 20 seconds to move from Q to R. From Q, this is a point Q, and this is a point R. It takes 20 seconds to move from Q to R. What is the average speed from Q to R? So here the average speed is nothing but the total distance divided by total time. At speed is the distance divided by time, but whenever if they ask the average speed, it is nothing but the total distance divided by total time. So from Q to R, the time is already given, that's nothing but 20 seconds. But what is the distance traveled between the Q to R? You can see from P to R, the distance traveled is nothing but 12 centimeter. It started from 0 at point P and it covered 12 centimeter at R. So from P to R, it is 12 centimeter, and from P to Q, it is nothing but 2 centimeter. So the distance traveled between Q to R is nothing but this much distance. You can see this much distance, and this much distance is nothing but this 12 minus this 2, that is nothing but 10. Okay, so this QR is what? This is nothing but PR minus PQ. Okay, so PR is nothing but 12 and PQ is nothing but 2. So this much distance is nothing but 12 minus 2, that is 10. So here you can write this total distance is what? How much is 12 minus 2? 12 minus 2. Here I will put these numbers in bracket, divided by the total time taken, that's nothing but 20 seconds. So here in this case the journey is nothing but along the straight line only, so there is no difference between the distance and displacement. Whenever it is a straight line, the distance and displacement both are the same thing. Okay, so that's why we have calculated PR minus PQ, that is nothing but 10 by 20 centimeter by second is the value. Here option number B, you can see that it is nothing but 12 minus 2 divided by 20 centimeter by second. So this is nothing but our answer. So they are asking between Q to R, that's why this 12 by 20 cannot be answered. It is actually for PR. Okay, it is for distance PR, that is nothing but 12. This is given reverse way, this is 20 by 12, cannot be the answer, and here also it is given by 20 divided by 12 minus 2. 20 is basically the time, so it has to be in the denominator. So only option number B is the correct. And then our last question, question number 10. A racing car is fitted with an onboard computer. Every time the car passes the starting line, the computer records the distance traveled in next 2 seconds. Okay? Which state of the data shows that the car is increasing in the speed during the 2 seconds? Okay? So you can see this data is collected, the distance and the time, okay, and they are asking about when the car is increasing in the speed. Okay, and the data is distance and time. So we know that if the distance and data is given, the slope of that data, okay, that is nothing but change in the distance divided by change in time is nothing but the speed. It is nothing but distance by time. So this rate should be increasing in order to get the increasing speed. So here you can see option number A, the time is going from 0 to 1, 1 to 2 seconds, and the distance is going from 0 to 100 and 100 to 200 meter. Okay, so you can see this distance between this 0 to 1, the change in the distance is nothing but this, that is, it is going from 0 to 100. So change is how much? This change is nothing but 100, that is 100 minus 0 is nothing but 100. And from 1 to 2 seconds, the change is nothing but this, that is from 100 to 200, so it will be 200 minus 100. So change in the distance is nothing but 100. So if the change in the distance is a constant, then we can say it is moving with the constant speed. Okay, because the change in time is also 1 and change in distance is also 100. In option number B, you can see if it is going from 0 to 1, 1 to 2, the change in time is 1 second. Change in the distance is what in the first 1 second, 90 minus 0, that will be 90 meter. It is from 90 to 180, so we can say the change in the distance is 180 minus 90, that is again 90 meter. The change in the distance is constant, change in the time is also 1 second, so we can say constant distance divided by constant time, that will be the constant speed. Okay, because the slope will be here constant. For option number C, you can see it is going from 0 to 1 second, 1 to 2 second. So here the change in the distance is 80 minus 0. For first 1 second, the change in the distance is 80 meter. The next second, you can say 0 to 1 to 2, it is nothing but 190 minus 80. Okay, so 190 minus 80 is how much? It is nothing but 110. It is nothing but 110. So change in the distance is basically increasing. Okay? Change in the time is constant, but change in the distance is you can say increasing. And if it is increasing, we can say the speed is increasing. Speed must increase. So here I can say the option number C can be the correct answer. So here you can see for option number D, the change in time is constant, but here the change in distance is 100, and change in distance again is nothing but 100 to 180 is 180 minus 100, that will be 80. So here what would I say? Here the speed is basically decreasing. Speed is decreasing. So option number C only we can say the speed is increasing. Option number A and B, speed is constant. For C it is increasing. For D it is decreasing. So option number C is the correct answer. Now we will see the structure problems. Now we will start with the structure problems in the worksheet for the chapter motion. Here you can see the question number 1. Figure 1.1 shows the speed time graph for the two falling balls, which both balls fall from the same height above the ground. You can see here, this is the speed time graph which is given on the y-axis. It is given the speed. On the x-axis it is nothing but time. So we can see these are two balls. First ball is a rubber ball, second ball is a plastic ball. For the rubber ball we have this straight line, here straight inclined line passing to the origin. And for the plastic ball, first of all the speed is increasing, and then after some time it is slowly increasing, you can say, and after some time it is becoming constant. So here the question number A, use the graph to find first the average acceleration of the falling rubber ball during the first 3 seconds. They are asking the average acceleration for the falling rubber ball. For the rubber ball. So you can see this line, the rubber ball, we have the straight inclined line passing to the origin. And since it is a speed time graph, for the speed time graph, we know the slope is nothing but the acceleration. Slope is nothing but the acceleration. So here we need to find out the slope of this graph to find out the acceleration. So I will select the 2 points. The first point should be the origin O, and the second point I am selecting this point. So to find out the slope we have to select these 2 points. Here I will write down the formula for the acceleration. Acceleration is nothing but the slope, and that is nothing but over here acceleration will be equal to the final velocity minus the initial velocity divided by the time. Okay, so that is nothing but the change in the velocity divided by change in the time. Okay, so what is the change in velocity? Basically the initial velocity you can see initial speed here. it is nothing but 0, and the final speed, you can see it is nothing but the this point you can see, if you observe this on the y-axis, this point is coming closely over here. This point is coming closely over here. So it is from 10 to 20, 30. You can see there are 10 divisions, and this point is exactly between 8 and 9 divisions. So you can see this final speed is nothing but the 28.5. Okay, because this 8 line is 28, 9th line is 29, so it is between this 28 and 29. So you can see it is 28.5. So initial you can say initial is 0 and the final is 28.5. And here on the time axis, you can see initial time is 0 and the final point is this is nothing but the 3 seconds. So change in the time is nothing but 3 seconds, and change in the speed is nothing but 28.5. So this is nothing but the change in velocity divided by time. So whether you consider the speed or velocity, it is the same thing here, because we are going to consider the magnitude, and this is a straight line motion, because both the balls are falling freely under the gravity, so they are covering the straight line path. So for the straight line, the speed and velocity are the same thing. So here we can say the final speed is nothing but 28.5, and initial speed was 0, and the time axis, we have the time given is nothing but final time is 3 and initial time was 0 second. So change in the here the change in the speed divided by change in the time. So change in speed is what? That is 28.5 minus 0, that is nothing but 28.5, and change in time is 3 minus 0, that will be equal to 3. So here 28.5 divided by 3, it is coming around 9.5 meter by second square. Okay, the unit for the acceleration is meter by second square. Okay, so our value is 9.5. So here again I will write 9.5 meter by second square. So always remember, for the speed time graph, the slope is acceleration, that will be change in speed divided by change in time. So for that you have to select any 2 points. Here I have selected the extreme points. You can select any 2 points on this straight line, and you can calculate the change in speed divided by change in time. Okay. So the second question in the part A is the distance fallen by the rubber ball during these 3 seconds. Okay. So again, we know that speed is nothing but distance by time. Here the distance is nothing but speed multiplied by time, and we have calculated many sums that the in the speed time graph, the distance traveled is nothing but the area under the curve. So here you can say we have to calculate this area. We have to calculate this area basically, and this area is nothing but the area under the curve. We have to calculate this particular area from 0 to 28 meter by 28.5 meter by second. So the distance is equal to speed multiplied by time that is nothing but area under the curve, area under curve, or area under the graph, you can say, or line, that is nothing but half into base into height, half into base into height. So here we can see what is a base. Base is nothing but this line. This is a right angle triangle, you can say. The base is nothing but from 0 to 3 seconds, so base is nothing but 3 seconds, and the height is nothing from 0 to 28.5, so height is nothing but 28.5. So here I can write down, so here half, that is 1 by 2, that is 0.5, Up into base is nothing but 3 second, height is nothing but 28.5, and if you calculate this value is coming out to be 42.8, closely about that. So here 42.8 is 8 meter is nothing but the distance covered during these 3 seconds. So here final value you can write down 42.8 meter. So the area is nothing but the distance. The third question in this part A is nothing but the terminal velocity of the plastic ball. So what is the terminal velocity? It is nothing but the constant velocity that is achieved by an object which is falling freely under the gravity. Here you can see the plastic ball is starting from zero velocity. As the time increases, the speed increases, and here the rate of increasing the speed decreases, and after that it is achieving the constant value. That means it is increasing slowly and then it achieves the constant value. And it achieves the constant value, that is nothing but, you can see here it is closely about the 15 seconds. So it is nothing but this value. This is exactly the fifth division. You can see this is 10, this is 11, 12, 13, 14, 15. So this value is nothing but 15 meter by second. Okay. For this horizontal line, the value on the y-axis is 15 meter by second. So this is the constant value achieved by the plastic ball. So the plastic ball, the terminal velocity is nothing but 15 meter by second. Okay, now we will see the part B of the question. Both balls have the same mass, but the volume of the plastic ball is much greater than the rubber ball. Okay, this is very important point here. The volume of the plastic ball is much greater. Explain in terms of the forces acting on each ball why the plastic ball reaches the terminal velocity but the rubber ball does not. Okay, so here this is the concept of the terminal velocity, what we should recollect. So whenever the object is falling freely under the gravity, we know that in the downward direction, basically the gravitational force or the weight of the object is acting, and in the upward direction we get the air resistance in the upward direction. Okay, so this we can say it is nothing but the gravitational force, or that is nothing but, in the simple word we can say it is nothing but the weight of the object. And in the upward direction we have the air resistance. Okay, this is nothing but the air resistance. So these two forces are acting in the opposite direction, and when these two forces become equal, then the constant velocity, that is nothing but called as the terminal velocity, is achieved. But this weight of the object, this solely depends on the mass of the object. Okay, if the mass is more, then weight will be more. But in our question, you can see the mass of both the object is same, so weight will be the same. But the air resistance, this depends on the volume or the area of the object. Okay, the surface area of the object. If the volume is more, so here you can see the plastic ball is having more volume. So more volume, that means it will be having the bigger surface area, and for the bigger surface area, the air resistance will be bigger, and that's why the air resistance acting on the plastic ball will be more than the this rubber ball, and that's why the plastic ball will achieve the terminal velocity, because soon the air resistance will be having the equal value with the gravity or the weight, and the two forces will be equal and opposite at that time, and the plastic ball may achieve the constant velocity or the terminal velocity. So you can write down over here the air resistance air resistance on the plastic ball is larger due to its larger volume or area. If the volume is more, you can see the area will also be more. So for the large volume or the surface area, their resistance, air resistance for the plastic ball will be more. But for the rubber ball, it will be smaller, and because of the smaller air resistance, it is not enough to balance the weight. But for the plastic ball, that air resistance will be enough to balance the weight. And when it is equal and opposite to the weight, then only we can get the terminal velocity. So we can write down for the rubber ball, the air resistance is not enough to balance weight. Okay, it is not enough to balance the weight, but for plastic ball, you can write air resistance is enough to balance. It is enough to balance the weight. Okay. So weight of the both the object is same, but due to the higher air resistance of the plastic ball, this air resistance is enough to balance the weight. And only when the air resistance and the weight are balanced, the object will achieve the terminal velocity. So this answer you can write down. Then the C part of the question, the rubber ball has a mass of 50 gram. Calculate the gravitational force acting on the rubber ball. So the gravitational force is what? It is nothing but the mass into the acceleration. So you can write down here the weight or gravitational force, that is nothing but the weight. You can write down either. Writing down both is not necessary. That is nothing but mass into acceleration due to gravity, that is given by the letter G here. So we have to convert, first of all, this is given in terms of the gram. So we have to convert that gram into the kilogram. So 50 gram is how much? 50 gram is nothing but 0.050 kilogram. You have to multiply that with 10 raised to minus 3. So 50 into 10 raised to minus 3 will become 0.050. And the value of the gravity is nothing but 10 meter by second square. So it is actually 9.8 meter by second square, but for simplification you can simply write down it is nothing but 10 meter by second square. So 0.050 into 10, the value is nothing but 0.5. 0.50 value you can write down. The answer is given in terms of the Newton, because so here weight or gravitational force is given in terms of the Newton. So final answer we can write down 0.50 Newton. Now the question number 2. Figure 1.1 shows speed time graph for a car traveling along the straight road. The graph shows how the speed of the car changes as the car passes through the small town. So here you can see it is nothing but the speed time graph given over here. On the y-axis speed and x-axis is nothing but time. So at point A, journey started. The speed is, you can see the speed is decreasing, and at this point B, it enters the town, and from point B to C, the speed is nothing but constant. And from point C, it leaves the town, and again you can see the speed is increasing till point D. So this is the graph. So the part A of the question, describe what happens to the speed of the car. What happens to the speed of the car? So here you can see this itself is a speed time graph only, and the graph itself is directly showing you the speed is decreasing from A to B, and from B to C it is constant, and from C to B it is nothing but increasing. Or you can also interpret it nothing but in terms of the acceleration. So here you can say The slope of the speed time graph is nothing but acceleration. If the speed increases, we can say for the straight line it is a constant acceleration. We can say from C to D. Here you can see the speed is decreasing. So this is nothing but negative slope will get. It is called as negative acceleration, or you can say it is nothing but the deceleration. Okay, so if you can either interpret in some in terms of this in terms of the speed or in terms of the acceleration. This is the reference slide I have attached over here. The slope of the speed time graph for the different lines is shown over here. So between A and B here, between A and B, we can see the speed is clearly decreasing, or we get the negative acceleration, that is also called as the deceleration. So here we can write down speed decreases, or that is nothing but the deceleration. Deceleration is nothing but the negative acceleration. Okay. From B to C, we can see here this B to C, the speed is having the constant value. This is nothing but the horizontal value. So speed is constant. Speed is constant. Now from C to D, here you can see from C to D, the speed is increasing with the steady rate. So we will get here the constant acceleration. So we can write down here the speed is increasing. That is nothing but acceleration. Now the part B of the question here. Calculate the distance between the start of the town and the end of the town. So we know that the speed time graph, the distance is nothing but the area. So speed is distance by time, distance is speed into time, which is nothing but the area under the curve. So here you can see it is nothing but between the start and end of the town. At point B it is the start, at point C it is nothing but the end. So we have to calculate the area under the graph. Here I can show here with the red line. This is the start from the B. So you can see this value is nothing but the starting point. This is the starting point basically, and this one is the ending point of the town. So between these two lines we have to calculate the area, and here you can see this is nothing but the rectangle we are getting. This particular rectangle is the area which gives you the distance. So here I will write down first of all the distance is equal to speed multiplied by time. So that is nothing but the area under graph. So here area under graph is nothing but the rectangle. Area of the rectangle is base into height. So we need to know what is the base and height of this rectangle. So here you can see there are 10 divisions between this 10 to 20, and this is nothing but 18 division you can say. So time over here it is nothing but I can write it is nothing but 18 seconds, and here the time is nothing but about this is a second division, so time is nothing but 42 seconds. So this one is nothing but the base of the you can say the rectangle, that is nothing but the length of the base. You can say the 42 minus 18, that will be coming out to be around 24. And on the y-axis you can see this is nothing but our height of the rectangle. This value is coming out, this is close to this line, and this line you can see this is nothing but about 13 meter per second. Okay, because here there are 10 divisions between the 10 and 15, so each two division is nothing but 1 meter per second. So these are, you can see these are about 6 divisions. So this 6 divisions means the increase of 3 meter per second, so it will be 13 meter per second. So height of the rectangle is 13 meter per second, and the base is nothing but about this will be 24. That is 42 minus 18. So here we can write down the base of the rectangle, that will be 24. Height is about 13. So if you calculate this value, 24 multiplied by 13, that is coming out to be 312 meter. So that is nothing but the distance between the start and the end of the town. So it is nothing but 312 meter. Here you can see part C of the question: calculate the acceleration of the car between C and D. And we know that in the distance, sorry, speed time graph, the slope of the graph is nothing but the acceleration that we have calculated many times. Between C and D, we have to calculate the acceleration. So I can select any 2 points here. For simplification, I am selecting this point C and this point D directly. So the slope of this line we can directly calculate. So here you can see this will be our initial velocity. Initial velocity will be here 13 only. The initial velocity is nothing but the 13, and the final velocity at point D. At point D, it is nothing but about 31. Okay, it is nothing but about 31. So final velocity, you can say it is corresponding to point B is 31, initial velocity is 13. So here initial time is 42, and the final time here with respect to point D. So the final value corresponding to point D is coming out to be around this point. So about this point, it is nothing but equal to 54. Okay. So the change in time is nothing but from, if you select point C to D, the change in time is nothing but this is nothing but 54 minus 42, that is coming out to be around 12 seconds. And on the y-axis, you can see from point C to D, it is coming. This is nothing but this much difference will get 13, and from 13 to 31. So 31 minus 13, that is coming out to be around 18 meter by second. So we know that on the graph we have to select any 2 points. We can select any 2 points on this CD line. So I am selecting the two extreme points C and D. So we should know the speeds corresponding to D and C. With respect to C, it is 13. With respect to D, it is 31. So difference is nothing but 18 meter by second, and the time with respect to C and D is 42 and 54. So difference is nothing but 54 minus 42, that is nothing but 12. So the change in time is 12, change in speed is nothing but 18. So here, so we can write down over here the acceleration is nothing but equal to the slope or the gradient of the graph, slope of the graph, or that is nothing but the change in speed divided by change in the time. So here we can put the values directly. The slope of the graph is nothing but the gradient is nothing but change in speed, that is nothing but 18, divided by change in the time, that is nothing but the 12. So 18 by 12 is coming out to be 1.5 meter by second squared. So this way we can calculate the acceleration. So that is coming out to be 1.5 meter by second square. We can also write down the speed acceleration is nothing but the, you can also put the value write down in terms of the equation, that is the final velocity minus initial velocity divided by the change in time. We can consider that is nothing but t. So here change in speed is 18. The time given is nothing but 12 seconds, or time taken is nothing but 12 seconds. Now the part D of the question is state how the graph shows that deceleration of the car has the same numerical value as the acceleration. So whether we calculate the deceleration or the acceleration, deceleration is nothing but negative acceleration, that is to be calculated with the slope only. So if you see this line, if you calculate the slope of this line AB, that is nothing but deceleration, or if you calculate the slope of this line, that is nothing but CD, then you can see the slope of the both the lines will become same. So only the difference. For AB we will get the negative value, here for CD we will get the positive value. That will be only the difference. So here it will get we will get minus 1.5 for CD, so slope will be plus 1.5. The numerical value will be same, that is 1.5. So we can write down over here the slope or gradient of the graph will be same. Okay, so since the slope of the graph will be same, that means the numerical value of acceleration and deceleration will be constant. Now we will see the third problem. You can read problem here. Figure 1.1 shows the distance time graph for the moving object. So the distance time graph is given over here. You can see from A to B the line is curved, and from B to C it is a straight line. So the part A of the question, describe the speed of the object between the points. So they are asking about the speed, and we know that distance time graph, the slope is nothing but the speed. Okay, so we have to decide here from A to B, between A to B and between the B and C. So here from A to B we have to determine what is the nature of the slope, and the nature of slope itself is the nature of the speed. Here the reference slide is attached over here. We can see steeper is the line, higher is the slope, so higher is the speed. If I consider here, if suppose this y-axis is nothing but the distance, and x-axis if I assume the time, then the slope of the graph will become the speed. So from A to B, you can see the steepness of the curve is decreasing basically. Steepness of the curve is decreasing. You can see it is moving like this, and then it is moving like this. So steepness of the curve is decreasing, and as the steepness is decreasing, we can say the slope is also decreasing from A to B. And if the slope is decreasing, we can say nothing but the speed of the object is also decreasing. So here in terms of speed, we can write down from A to B, speed is basically decreasing. And from B to C, we can say it is nothing but the straight line. We had also seen one slide while learning the that is nothing but for the straight line, the slope is always constant. For curve line, it is nothing but variable. So B to C is a straight line. For the straight line, we always get the constant slope. Constant slope means the constant speed. So here we can write down the speed is constant. Okay, so we are interpreting this distance time graph in terms of the speed. From A to B, the steepness decreases, that means slope decreases, so speed is decreasing. And B to C, there is a straight line. Straight line, the slope is constant, so the speed is also constant. Now the part B of the question, state whether the acceleration of the object is zero, negative or positive as shown on the graph between the points. So here we need to tell about the nature of the acceleration between A and B and B and C. The very important point is that they are asking about the acceleration, and the graph given is nothing but the distance time. Okay, so distance time graph, or the slope of this kind of graph, will only give us the idea about the speed, not about the acceleration directly. So we have to decide the nature of the acceleration from the answers given in part A, that is nothing but from the speed. Okay, so from the speed we have to decide what would be the acceleration. The part A, we can see part 1 from B to C, A to B, the speed is decreasing. From B to C, it is nothing but constant. So for reference, I will go to the this diagram. This is the reference diagram for the speed time graph. This is giving us the idea of how the acceleration changes with the speed. So we can see here from B to C, the speed is nothing but constant. So if the speed is constant, the acceleration is zero. And from C to D, the speed is decreasing. In that case, we are getting the acceleration is nothing but minus or negative constant value. That is nothing but deceleration, or we can say the negative acceleration. So this acceleration is nothing but the slope of the speed time graph, and for the constant speed it is 0, and for decreasing speed it is nothing but negative value. So these speeds are giving you the idea of what kind of acceleration is there. So from A to B we can say, as the speed is decreasing, the acceleration is negative. So we can write down it is nothing but the negative acceleration. And from B to C we have a constant speed, so the value of the acceleration will be 0. So here we can say it is 0 acceleration. 0 acceleration. So speed time graph is giving us the idea of speed, and then from this speed we are estimating what could be the value of acceleration. Now the part C and the last part of the question is that calculate the average speed of the object during 40 seconds. And we know the average speed is nothing but total distance divided by total time. The speed is nothing but distance by time, but when we say the average speed, is precisely it is nothing but total distance divided by total time. So it is nothing but the we can say the slope of this graph, and here I can write down first formula. The average speed is nothing but equal to distance divided by time. So we need to see here, we need to calculate the average speed for this much time duration, that is nothing but 40 seconds. So here you can see from 0 to 40 seconds, that means this much of time interval, how much distance, how much total distance is covered by the object. It is going from here 0 to 50. Okay, this is the total distance traveled by the object. So it is going from 0 to 50 meters. So we can say in the time span of 40 seconds, it has covered the total distance of 50 meters. So we can put this value in the formula. So here the total distance is nothing but 50 meter, time taken is 40 seconds. So 50 divided by 40, we are getting this value is about 1.25 meter by second. So our final value of this speed is nothing but 1.25 meter by second. So here we are going to end up our problems. Thank you so much.